What's going on, ladies and gentlemen? Thank you so much for tuning in. It's me, Mikey Pipes. If you're in the Long Island, New York City metropolitan area and you have a Hayward pool heater or any other pool heater and you need help, give me a call, 516-348-6300. Prompt, professional, and courteous service is available in the Long Island, New York City metropolitan area. You can book an appointment online at pipedoc.net. Let's get going. All right, working on a Hayward HeatPro. We've been coming here for a number of years. Customers complained the other day, system stopped working and the system is giving off an atmospheric smell. I don't know about you, but it smells like refrigerant to me. It's got that distinctive smell. You know what I'm talking about, you HVAC freaks. Yeah, my mastic tape is still working quite well right there. I'll check our onboard fuse. That also looks good. You could test that with a voltmeter and test for continuity in case you visually are impaired. What's up with this? I don't know. This is a ground. That goes nowhere. I don't remember ever cutting that, but I've been servicing this pool heater for quite a number of years. Last time was in June 7th, 22. Replaced that single capacitor for the fan motor and for the capacitor. Sorry. On June 7th, 22, I replaced the single capacitor for the compressor. I put in a dual that's going to run the condenser fan motor and the compressor. We're gonna have some starting to see our victim here. We have a burnt off wire right there. See that? She's dead. And that wire right there looking pretty frayed. I wonder what the cause here was, but definitely pretty sus right here. We're gonna pull the power and then we're gonna check for voltage there. Here's the disconnect. I removed the front cover and the inside piece. Pull power. And let's check for voltage. L1 and L2. Perfect, 250 volts. Let's go to ground. Right there, and L1. 120, good. Let's go to ground. And L2, also 120. So we know we're good there. Let's just check our load side of it, make sure there's nothing we're not seeing and we have no voltage there. So we're safe to proceed. Let's go back to our heat pump electrical compartment. So for starters, it looks like we're gonna have to replace a wire from there to here. We'll maybe give them a new whip or just replace the electrical on it. Let's check for any shorts to ground. Let's do that first, actually. Okay, so this is that victim wire. Let's check for shorts to ground. We're going to set our voltmeter to read continuity. See? And now, let's see if I can get in there and show you guys. Okay, there's ground to ground. Okay, and ground to there. Nothing there, nothing there, nothing there, nothing there. No shorts. Okay, so I'm going to proceed with replacing this contactor. All right, I'm replacing the L1, L2, and ground from the disconnect panel into the existing whip and to the electrical compartment right below the contactor. I got this wire right here from my truck. Pipe Doctor, we make our own whips. We don't buy whips pre-made. Reason for that is oftentimes when you're using a pre-made whip, you're throwing away a lot of it. And in this case, the liquid tight is good, nothing wrong with it. So I just disconnected L1, L2, the ground from there. We're gonna pull that out from here, and then I'm gonna push in the new wire from there. I may tape it onto there, but I'm just gonna, just pull it separately. All right, my new contactor is in. Pretty much a direct replacement, wire by wire, terminal by terminal. I want to take a closer look at this in a little minute, but see what the failure point here was. It's quite interesting. We'll take this top cover off, which is covering up the 2 poles on the 24-volt coil, and we'll see what's going on in here. I hope it's a 24-volt coil, and I think it is because we have a 24-volt control circuit. So I'm just going to wire in my ground L1, L2 over there, plug her in, and we'll keep our fingers crossed. All right, our system is running after about a 5-minute delay. We're going to let this balance itself out for a little bit. In the meantime, let's take our voltmeter and let's check for amperage and see how much power, or sorry, how much amperage this unit is pulling right now. I got my Fluke 902 FC. Let's set it to read amperage. Oh, let's make sure it's off first. Let's read amperage. There we go. Let's go over here. Let's check on line 1. We're using 24 amps, and on L2 also 24 amps. Our minimum circuitry. All right, we are at compressor normal 32, fan normal 1.8. Looks like we're good. We do need a max breaker of 70 and a minimum of 42. That's going to be a 50, obviously. But it looks like we're running. We're running good. All right, I got my little thermocouple tip in there. Right in there, see it? And we're reading, one-handedly, 96.5. My discharge temperature is 56 out of the top of the condenser fan motor, and it is 82 degrees out right now. I'm happy. Customer is now too. So ladies and gentlemen, if you found this video useful, I would really appreciate it if I can have your thoughts and feedback down in the comment section down below. And if you haven't done so already, the best way to support the channel is by subscribing. Do it now. Thank you.